Hello, everyone, and welcome to the Green Grid's Introduction to the IT Work Capacity Metric webinar. My name is Rebecca Rafferty, and I'm the Technical Program Manager at the Green Grid. With us today, we have Valerie Diehouse, the General Manager of the Green Grid, and Jay Dietrich, Chair of the ITE Metrics Work Group, who will be presenting. Thank you. With that, I will hand it over to Jay.
Good day to everyone and welcome. Today we're going to talk about a new metric that's been developed by the Green Grid ITE Metric Working Group. And this particular metric is focused on measuring or estimating the work capacity of the IT equipment in the data center. And we're going to look at the overall metric, but today we're going to be focusing on the use of perf CPU as the indicator capacity for standard CPU servers. So let's get into the meat of the discussion. So first of all, what is the IT work capacity? And in this case, it's version 1. So version 1, or the overall work capacity that we're interested in a data center, is the work that the servers do, the storage products, and the network products. Collectively, that's the total workload. For the purposes of analyzing how a data center performs, we're probably going to want to focus on each of the components of the data center, the equipment types of the data center individually. So this work that we've done is the first piece of the capacity measurement. And what we're looking at is the standard CPU-based servers. So it's servers that have Intel, AMD, ARM processors. And we're going to just talk about the work capacity for this group of servers. Right. This is important because standard CPU servers represent 80 to 90% of the installed servers in today's data centers. We have a lot of discussion and talk about AI servers, and it's certainly the most exciting area in the data center today, and it's an area of growth, but standard CPU servers still predominate. And so we're putting together a metric for this. It's targeted for the server capacity indicator CSERV that's required reporting for the EU Energy Efficiency Directive. And this is the first step towards creating an overall data center work capacity metric. But we're going to start with standard CPU servers. So why are these equipment capacity measurements important? You know, the data center industry and different working groups and different organizations have been bantering around capacity measurements for years, literally over a decade. But yet we haven't been able to coalesce on a working metric. And so the reality is, in today's environment, we need to build that efficiency metric. First of all, the EED requires storage and server capacity reporting. And that's something that operators are legally obligated to do today and for which there is no standard measurement. And then beyond that, we need to be able to translate that capacity into IT productivity, the deployed or utilized work capacity, and then the units of energy that deliver the work capacity itself. So that gets us our efficiency metric. And so the best option, the direction we think this has to head is that we take these total work capacities, apply the utilization values, the average utilization of the data center, which is something that operators can measure and which 50% of operators do measure, and then take that and divide it by the amount of energy consumed to run the servers to get a good productivity and efficiency metric. First of all, this metric will recognize the benefits of putting in new, higher capacity equipment and consolidating old equipment onto it. And so over time, if you look at the data center's history, we've been able to increase the amount of work capacity we do per unit of energy year to year. That's why the growth in energy use has been relatively flat the period of 2010 to 2020. This metric neatly combines facilities and IT energy consumption because you're going to use the total energy consumption for cooling and for IT, driving the IT equipment as your denominator of the equation. And that's where PUE comes in, because you take your IT energy and multiply that times your PUE. And it is going to show continued improvement for the industry. It speaks to the work we're able to do to get more and more computational work done for each unit of energy we consume. So work capacity is the foundation for this. It's the first important step to developing a work per energy metric down the road a ways. So now let's focus in on the standard CPU server and look at what do we need for the attributes of this metric. First of all, it has to give a reasonable indication of the work capacity, and it has to be representative for a server workload. One of the major problems we've had in trying to reach a consensus on a work capacity value for servers is this concern about, well, it has to match the workload I'm doing, or this particular capacity metric doesn't really represent what my server does. But what we need is an overall work capacity that gives a comparative server measurement, work capacity measurement, that recognizes that if I'm running a 32 core processor, I do a lot more work than I do for an 8-core processor made with the same technology generation. And if I go from a 32-core processor from a 3rd generation AMD EPYC processor and go to the same core count processor in the 4th generation, I'll get significantly more workload from that processor. And we need that to provide a comparative value that works across all the major vendors of standard CPU type servers. And this metric does that. We've developed data for all of the major, excuse me, standard CPU manufacturers, and we've been able to show that the work capacity value for each CPU is independent of the server configuration. So if you're running this a gold 6152 processor, that processor will have a work capacity, a given work capacity, no matter whether you're using 32 or 64 gigabits of memory or 128. This is going to then enable us, again, back to our earlier discussion about work per energy, a metric that will allow us to document our efficiency improvements, both increasing the utilization of an existing server that's installed in the data center, but which is running at a low utilization, and we will bring it up to higher utilization, and the work improvements that can be achieved by putting in new servers, refreshing and consolidating your server base. The metric we've selected for the work capacity is the perf CPU, and let's look at that metric. So the metric needs to be a measured active state performance. That's a requirement of the EED. It's also a requirement for just the capacity in general. You can't have an energy value or energy unit within that the active state performance capacity. Perf CPU is a perfect metric because, one, it's standardized. It is documented in a ETSI standard 303-470, and it represents the geometric mean of the normalized 100% performance values of the 7 CERT CPU worklets. And the group did quite a bit of work to show that the perf CPU value was a better value to use for server work capacity than the total work capacity of the server, which would include the work capacities of the memory and storage worklets. White paper 92, which is published on the Green Grid website, has a detailed analysis of the reasons that the perf CPU metric represents the best capacity metric for the CServe work capacity indicator for servers for EED, and for generally working on the analyzing the work capacity of your server infrastructure. And what we have been able to do is put together a set of lookup tables that give you the per CPU value by CPU SKU, where the GreenGrid database of cert measurements has a one or more configurations tested with that CPU. So let's look at, here's the table. These are the per CPU values that we have and are published in white paper 94 for the 5th generation Intel and AMD CPUs. So in this case, we've got 8 values for Intel products, 8 values for AMD products. And so in this case, for each installed CPU in the data center, let's say an EPYC 9315, each of those processors in the data center has a work capacity of 16.5 normalized transactions per second. And then the second step, and we'll look at that in more detail in a minute, is using the data where we know the core count and the per CPU value. We were able for each CPU generation and manufacturer to calculate the per CPU per core count for that technology generation. And we'll look at how we did that on the next slide. One important point here is many people are not familiar with the CPU SKU values and how you determine the technology generation of a given CPU. So let's look at our table here. We have got, you'll notice that all of the Intel processors have a 4-digit CPU SKU. They add on a 5th indicator, an alphabetic indicator at the end, but we're interested in that 4-digit number. The second digit of the Intel CPU SKU is the technology generation. So in this case, we see that all of the Intel numbers have 5 as the second digit of their part numbers, well, with the exception of the 8468, which helps me out. So those that have 5 are 5th generation. The 8468 is a 4th generation, and so it shouldn't be on this table. So that gives you an idea how this works. For AMD, it's the 4th digit of the 4-digit SKU. Again, they have an alphabetic indicator on some of their part numbers, but again, we're only interested in the 4 digits. And you look at the 4th digit of the CPU SKU. Again, it's a 5, so these are all 5th generation part numbers. And here we've got correctly all 5th generation part numbers. So within white paper 94, we have a table of the CPU SKUs where we had measured data for all 4 generations, or I'm sorry, all 5 generations of the Intel and AMD products. We have tables for the 2 generations Power 9 and Power 10 of the IBM Power products. And we have a few, some data on ARM processors. But that's an area we're going to work on building out over time. So now let's look at the core count process. So here we took the Intel data from the previous table and plotted that by the per CPU against the number of cores. And you see then that we're able to do a fairly decent line fit, linear curve fit to that set of points, and we're able to generate then a curve, a linear equation that allows us to calculate the per CPU value for the different core counts of processors that Intel or AMD manufactured. And we'll look at that in the next chart. But the important point here is that when you look at the trend lines and the accuracy, we get a reasonably decent R-squared value fit. So the range of R-squared values was 0.71 to 0.99 for all of the sets of data that we had. 12% of those had a 0.7 to 0.8 R-squared, and 98% range from 0.8 to 1 on their R-squared value. And we did get a 1 on our ARM processors because we only had two CPUs to generate the line. So by using this linear curve fit, we're able to provide per CPU values for all of the remaining products of each product generation. So again, within white paper 94, you're able to find tables for each generation of manufacturer showing the core count and the associated per CPU value. So for example, for Intel Xeon Gen 5, if you look on the Intel inventory of offered processors, there's 8 core to 64 core offerings in the Gen 5 family. And this would have been as of January of this year. For the epics, you've got core counts ranging from 8 to 192. So if you get another part number, and I provided 2 examples here, Intel Xeon has a 6745P with 32 cores. And so using the 32 core value, we end up with a per CPU of 18.4. So for those of you that look carefully at the numbers, you notice that this does have a 7 in the second digit. So again, I picked this off the inventory the other night, and so we're going to pretend it's a 6645, and we don't have one of those, and so that would be a 18.4 per CPU. But the example is to give you a sense of how this works. AMD, the 9645, we've got the 5th generation. It's a 96 core processor, so its per CPU would be 62.04. So you can take then that value for that per CPU and use that to calculate the work capacity for a server with those processors. So now let's take that those numbers, the per CPU values, and do a couple examples on how you'd get an overall CSERV value for a data center, or a total work capacity of the standard CPU servers in the data center. So the first methodology to do this is to just take an inventory of all the CPUs in the data center. So in the table, I've just created a small data center. It has 500 CPUs with 5 different part numbers. Again, these are all Gen 5 part numbers just to be able to match the calculation table to the per CPU tables that are on the earlier charts. And what we have to do here is first we've got our 5 part numbers. So my data center has 100 each of the silver, gold, platinum, and the 2 epic processors. So the first thing I have to do is look, okay, are these CPU SKUs in our CPU SKU lookup tables? And we see that in fact for the gold 5512 and both of the epic processors, we have per CPU values for those CPU SKUs. So we note those in our calculation table in the per CPU value by CPU. For the silver 4510 and the platinum 8592, we have to go to our lookup table for the core count. And those values then, let's just go back and look at one. The 8592 is 64 cores. So looking at the 64 core count, it's 35.59 for per CPU. And we have a 35.4 value. So small adjustment, but it makes the point. And so then what you do is you take those per CPU values and multiply them by the total number of CPUs in the data center to get your total CSERV value for each processor type. And then you accumulate that to get the total CSERV value for the data center. In this case, 18,910. So that is your IT work capacity version 1, or CSERV score, for the servers in your data center. Similarly, you can do it by server product. So in this case, we've got 4 server types in our data center. And we see those 4 there. The HPE Pro Alliance have the same processors in them, but they have a different number of populated sockets. The first set of servers has 2 sockets populated. Second set has 1 socket populated. For the Dell, we have 2 different server models with different processors in them. And again, we just look at the lookup tables and the core count tables to get the per CPU values. We note those values in our table, and then we multiply the physical core count, or I'm sorry, the number of sockets of the servers times the number of servers to get our total server work capacity for that set of servers in the data center. We do that for each set of servers, and again, add it up, in this case, to get a total value of 5528. And the overall score then, as noted, is 5528. Once again, I've made a calculation error. So this just shows how you can do it using your server inventory and the number of CPU sockets and the number and the CPU SKU and core count per CPU values to be able to calculate the total work capacity of the server infrastructure in your data center. There's a third method, which I didn't make a table for, but you could do the calculation just by using the core count tables. That's a little less accurate than using the measurements, but we ran one test with a multi-generational set of CPUs, and the error between doing CSER value using all of the measured per CPU values associated with the CPU SKUs was 4% below, 4% less than the CSER value using the estimated values generated for the core count. So you've got pretty good alignment there, and any of these 3 methodologies will allow you to calculate the total work capacity of the servers, standard CPU servers installed in the data center. So what's the advantage of this? Why is this important to the industry? First of all levels of government are searching for IT efficiency metrics. And it's really important, a critical component, really the foundation of those efficiency metrics are going to be some methodology to measure work capacity. And we're really, this is becoming important as we see the concern about the energy use of data centers, an interest in validating that the IT infrastructure is running efficiently. We've got a variety of different ways to measure the efficiency of the facilities infrastructure, but we really need to find an effective methodology to measure and assess the efficiency of the IT equipment running in the data center. You can have the best PUE in the world, but if your IT equipment is utilized at 10%, you don't have an efficient data center. You've got huge rooms for improvements. Internally, it provides you a metric to track your efficiency improvements. I would submit a CIO should be interested in looking at what his or her team has done to improve the work per megawatt hour delivered by their IT infrastructure year to year. It's an important look at how efficiently is it being run and how effectively are we making use of the assets we buy. And most importantly, from a regulatory standpoint, if you're refreshing and consolidating and working diligently and with discipline to optimize the utilization of the infrastructure you've got installed, you're going to be able to consistently show year-to-year productivity improvements in that infrastructure. And that's important, particularly in the context we're seeing many countries now requiring operators to do an energy management system and report their energy performance, and most of them are designating ISO 50001 as the standard by which that energy management system is constructed. Under that standard, you have to do an energy performance metric in the form of a productivity metric, work delivered per unit of energy consumed. Um, this metric, using capacity and the energy consumed by the servers that have that work capacity, is the perfect metric to use to satisfy those requirements under ISO 50001. The other thing that's really important about this uh, metric that we've developed in GreenGrid is that it's simple to use. Uh, all you need to do is to be able to count and aggregate the type and number of installed CPUs in your data center. And that allows you then to calculate, as we've shown you in our examples, the overall work capacity of the system. Now, that requires you to do that inventory. And again, we've done some survey work, which has shown that about 50% of operators have inventory that will allow them to access their CPU SKUs and generate a CSER value. But we've also done some additional work which shows that about 20% of operators have the data available that they could collect it and aggregate it in a space of about 6 to 12 months. And then there's 40% of the operators have some work to do to get it done. But it really is an important first step for the industry, and one that we need to take. And finally, it's important to engage with organizations that are working on building out the other components of with GreenGrid, I'm building out the other components of the IT work capacity, the accelerator, accelerator and GPU-based servers, storage equipment, and possibly in the future, the network equipment. So with that, that's our explanation for today. We think this will be a good tool for the industry. We're excited to work with IT operators to help them use the metric to calculate their work capacity, both specifically for regulatory reporting in the EU, but also to work on those energy performance metrics for their installed IT infrastructure. Thank you for your time and your interest.
Thank you so much, Jay, and thank you for watching. Don't forget white paper number 94, the IT Work Capacity Metric V1, a methodology, is currently available for free download in TGG's public library. And that concludes our webinar for today. Thank you all.
Thank you, Rebecca, and thank you, Jay, for presenting today.
Thank you.